Hey, this is Miss Lawson here for your review. Just a heads up, I will not be doing every problem for you, but I will walk you through a couple from each set. And remember, the answers are posted in the back of your homework packet, so you can check the ones that I don't do with you with the answers in the back. So we are going to start with graphing, and just so you know, the bell's going to ring, just bear with the sound. So sketching the graph, we've got our two shapes, and what I'm going to do first, I think, is I'll just do the first problem with you guys. And we need our x values. So remember, throughout this whole chapter, we've picked, or whole year, -2, -1, 0, 1, and 2. And then when I put them into my parent function, which remember the parent function is 1 over x, I will get -1/2, sorry, -1, 0 will not work, and then the numbers repeat, but just without the negative signs. So this table is what I'll use in problem 2 and problem 3. So let me first talk about the transformations, which I probably should have started with. So this 3 is going to be a stretch. This 4 is going to be up 4, and this 1 is going to make me go right 1. So if you want to list them here in the transformations, you can. It's a stretch 3, up 4, right 1. So what we do first is we take our table and we apply any stretch or compress or flip. So what I'll be doing is taking all of these old y's and I'll multiply them by 3. So I'll be taking -1/2 times 3. So what I do is I just start half of 3, which is 1.5. And then the negative and the positive will make that negative. And -1 times 3 is -3. And then again, 0 doesn't happen, and then the numbers repeat. It's just the opposite sign. So the negatives become positives. So from there, what we talked about is actually graphing your walls first, so using a highlighter. So I'm going to start with that. And I'm going to take my vertical asymptote, and it's going to move right 1. Right there. Okay. And then I will take my horizontal asymptote and move it up 4. So let's make that a little bit bigger. That's a little too big. Let's see. 4. Not a great straight line. Anyway, these equations are, I have x equals 1, and then I have y equals 4. So the idea is if I've graphed my walls, then I can just graph my transformed points from there, because the walls move the points already. So I'm going to quickly just kind of very lightly scribble out the y's I don't want. I don't really care for these. And now I'm going to go through and I'm going to graph my points. So I'm going to think of these as directions starting from right here, this dot here. That dot is not part of my actual points. So I'll be going left 2 and up 1.5, and that ends me about there. And then I'll be going, sorry, not there, left 2 and then down 1.5. I went up 1.5. And then I will be going left 1 and down 3, which puts me here. So here's my first shape. I'll graph it in a different color though. Okay, and then I'll take my other points. So from that red dot where the 2 yellow lines are crossing, I'm going to go right 1 and up 3. And then I'll be going right 2 and up 1.5. Well, that's about there. And I'll graph those. Not that great. And from there, I will want to fill in my arrows. So I'm going to start with this arrow on the right. It's going to the right. So for as far as x goes, I have infinity. And it is going down, but it's going to hit the wall of 4. And then if I go to the arrow on the left, we talked about that it's pretty much going to be infinity 4, but it's going to be -infinity 4. That was a nice pattern that we noticed. And then I take care of the up arrows. So the arrow at the very top, x is going to the left, but it is getting stopped at x is 1, but it keeps going up, so y is infinity. And then the arrow at the bottom is pretty much the same, except the infinity becomes negative. So if you can get 2 of the arrows, the other 2 go pretty fast. So as far as domain goes, remember domain is just your x. So I've got 2 shapes, so I've got 2 domains. Okay. And it starts with x being -infinity, starts really small, and then it gets bigger until x hits the wall at 1. And then I told you guys, think of it as jumping over the wall, picking back up at 1, and then going to infinity. And then the range, I'll just do the same for the y values. So the smallest y we wrote was -infinity. It moved up until we hit the wall of 4. It jumps over the wall, picks back up at 4, and goes to infinity. And then end behavior. In this one, I'm only asking for one of the end behaviors. So if x is infinity, what's the y, or what's g of x? It is 4. So you guys should try the others, all right? So just a quick note, this would be a flip for the negative, this would be down 3, and this would be left 1. And again, your points to start out with are -2, -1, 0, 1, and 2, and your y values, -0.5, -1, nothing for 0, 1 and a half. Okay, so hopefully you get the other graphs. Again, just check the answers in the back, see how those look. And I'm going to go ahead and move on to the next section. So for this section, I'll do a few from each part. I will start with number 5 because I think number 5 is the slightly tougher problem. And my job is to simplify, so I want to factor the numerator and the denominator all the way, and then I will be checking to make sure I get my domain issues, and that's where I'll be focusing on the denominator right here. Okay, so the bell's going to ring. Again, just bear with it. So the first step of all factoring, here's my numerator, is a GCF. So what I notice in my numerator is that I can take an x out of all of those. So I'm just going to put my work over here. And you can always put your work on a different piece of paper, but from there I'll have 6x squared plus x minus 2. And then from there I want to try to factor this. So this is 3 terms, but it's not easy factoring because of that 6. So this will take a little bit more work, and there's definitely a not easy factoring on the test. So I need factors of -12 x squared. I got that from multiplying those two. That give me 1x. That's this middle term. So those two side numbers will be 4 and 3, with 3 being negative. And again, it's not easy factoring, so I am going to have to rewrite this. So I'm going to use the space on the left. I'll rewrite this as 6x squared, and then I got plus 4x minus 3x minus 2. Again, I'm factoring this, okay? So from there, I should group the first 2 and the last 2, and I just do a GCF. So when I GCF this first set, I take a 2x out, and then I'm left with 3x plus 2. When I go for the second set of parentheses, they are matching. And so I'm trying to figure out what multiplied here to 3x to give me the -3x, and that's a -1. And then from there, I get my factors. So I'm going to erase my x here. And the denominator now becomes 2x. I'm sorry. Well, I don't want to put it there. Here's my problem. It becomes the x that I took out, and then my new factors of 2x minus 1 and 3x plus 2. So the numerator is factored all the way. So now I'm going to do the denominator. So in a different color, I'm looking for a GCF. I notice I can factor out an x squared from both of those, and then I'm left with 9x squared minus 4. So the x squared is going to come over here and join this, but then I'm going to try to factor this, and this is what we call a difference of squares. It's a difference because you see the subtraction, and then each of these terms are perfect squares, meaning they have nice square roots. So the square root of 9x squared is 3x, the square root of 4 is 2, and then I can make this into 3x plus 2 and 3x minus 2. So this problem definitely involved a lot of factoring, but don't be alarmed by that. You guys can handle it. So now I'm going to look for my common factors from the top and the bottom, numerator and denominator, and cross those out. So I notice I can cross out a 3x plus 2. And even these x's, if you think of this x squared down here as 2 x's, right? One of these x's can take out one of these x's. So when I'm done, what's left in the numerator is 2x minus 1. Good idea, just to keep it in parentheses. And then the denominator is x and 3x minus 2. So as far as my simplified answer goes, that's my simplified answer. And then I still want to do this part of checking the domain or the denominator for my domain restrictions. So the part I'm going to check is actually the unsimplified part. So I want to see what makes this 0, what makes this 0, and what makes this 0. So I'll start with the x squared. So in the end, I do not want x squared to be 0. So to solve for x, to get rid of a squared, I square root. So I don't want 0 because the square root of 0 is 0. And then I'm going to set the other one, 3x plus 2 equal to 0, and I'm going to subtract 2. and then I'll divide by 3. So the other value I don't want is negative 2/3. Let's circle these. And then I'll do the same but with 3x plus 2. That can't be 0. So this time I'll oh, sorry, not that one. I already did that one. Minus 2. So now I'll add 2 and divide by 3, and so I wouldn't pick 2/3. So as far as my domain restrictions go, don't pick 0, don't pick negative 2/3, and don't pick 2/3, and then we just get our overall answer right here. Okay? All right, let's take care of a problem from the next set. So these are all pretty similar because they are all going to be involving multiplying or dividing. So I'm going to do a multiplying for you and a dividing for you. So again, this is where I just want to factor everything like I haven't factored before. So starting with, let's see, let's take a look. I will do number 6 for you guys. So I'm going to start with the top left numerator, and I'm going to factor out a GCF of x squared, and then I'm left with x minus 5. I can't factor x minus 5 anymore. I'm going to move to the denominator. I cannot factor x plus 7 at all. There's no GCF. It's not a difference of squares. There's not 3 terms. Factoring my numerator in the top right, I first look for a GCF here. There's not something I can take out of all of them. So I'm going to go to my x for 3 terms. This will be easy factoring because this is an x squared here. So I need factors of negative 7x squared. They get me to 6x, and those factors are 7 and 1, and I need for the 1 to be negative, so easy factoring. I can just make this x plus 7 and x minus 1, and then the denominator can't really factor out, so I'll leave it as 4x squared. So now I'm going to look for the common factors between my numerator and my denominator and cancel those out. So the obvious one is the x plus 7, but there's also the x squared, can take out this x squared, and then when I'm done, my numerator is x minus 5, x minus 1, and then I still have that 4 in the denominator. So that is number 6. Let's take a look. Let's do number 8. So this is division. I'll remember to copy dot plot, but my first fraction I'm just going to factor and leave it in numerator as numerator. So in the 4x squared, I can factor out a 4x. That's my GCF, and I'm left with x plus 3. I can't factor x plus 3 any further. My denominator, there is no GCF, but with 3 terms, I would want to make my x. So I need factors of negative 3 to get me to 2. And those factors are 1 and 3, with the 1 being negative. It is easy factoring, so I can go straight to my parentheses, x minus 1, x plus 3. Now I'm going to dot, and the 4x will flip-flop to the bottom, and this 5x minus 1 I will factor. I'll start with the GCF. I can take a 5 out, and then I'm left with x minus 1. I cannot factor x minus 1 any further. So what are those common factors between the top and the bottom? Well, first I can take out this 4x and this 4x. I can take out an x minus 1 and an x minus 1. I can factor out the x plus 3s. So when I'm done, I am only left with 5. So the other ones are very similar. Most of the factoring is pretty basic. I will point out that on number 7, this denominator here, this is not easy factoring. So make sure after you make your x that you rewrite it as the 4 terms, okay? All right, that is the first part. So the next video will pick up with the adding, subtracting, and solving.